Hey guys, Harris here. Hopefully you guys are doing well, and this is the third video on functional programming. And basically I'm gonna continue with those last notebook, right, where I'm using about the functional programming and we're building an algorithm, right? So in future we're gonna build more algorithms. So let's talk about recursion, right? What is a recursion, right? Well, if we have a proper definitions in a technical term in programming, we say recursion is a programming technique in which program call itself directly or indirectly to solve a problem, right, by breaking down into smaller instant of a same problem. Well, it is a powerful concept used in many algorithm and programming language. So if you learn recursion basic and you understand what is recursion, if you are doing JavaScript, if you are doing Node.js, right, if you are doing Java or any C language, basically it will be easy to understand and implement those kind of basic while learning those language, right? So recursion involve two essential components, let's say base case and recursive case, right? So basically a base case is a condition that defined as simplest form of problem which doesn't require further recursion, right? The base case act as a termination conditions for the recursion call, right? And when it's come to the recursion case, the part of the function where it's called itself a modified input to solve a smaller instance of problem, which recursion will bring problem closer to the base case, right? So I'm gonna show you some code which basically gonna help you to understand how the recursion look like, right? Okay guys, so let's start with a simple example. So basically I'm gonna make a factorial function. Basically it's very easy and it is available everywhere, right? So let's say def, right, let's say factorial, right? Then I'm gonna define an argument. Basically in a open and close parentheses we define the argument and we use a semicolon. Then we'll say control flow statement is a for loop, but I don't want to use any for loop over here. I want to use just the simple condition loop, right? And well, if I say if, right, where n is our argument, right? So if I say if n, which we are taking argument inside our functions, equal to 0, which is comparing the value. If the value is 0, then it will return 1, right? Or else if n is not equal to 0, right, it will return and time, right? That is the most tricky part over here. Return and basically it's going to return the value of n, which is the argument. Then say factorial, right, factorial, and basically the argument inside the factorial will be n minus 1. So that is our recursional case, right? So basically we are using function inside the function. We can say nested functions, but it is not basically a nested function. We are returning something, right? And we are multiplying those argument with our new argument, right? So basically it's a recursion, right? So let's say number equal to 5 and let's say result equal to factorial, right? And we're gonna say number, right? So now you can see over here we're gonna print the result and our answer will be 120. So if you do a factorial of number 5, then you will get 120, right? It's very easy, right? So let's move on. I don't want to go through more permutation and combinations, right? So let's move on. And if you are in a high school or if you're in a college, you can build this code and you can solve those all the exam papers without even writing on the piece of a paper, right? It's really easy. Let's move on with another example. Let's say we want to make a recursion, right? And basically in this example we're gonna use the recursion function, right, to sum of all the sequences of number, right? So we're gonna sum all of them, right, with the help of recursion, right? Let's say def, right, let's say let me get this to more to top, right? So let's say sum recursive, right? So if my spelling is wrong, then never mind, right? So number, then I'll say if len, which basically len stand for the length, right? And I'll say number, right, basically the argument we're taking from here, right? So number, and we're putting inside the tuples, that is the rules of a len, right? So equal to 0, right, the semicolon, and we'll say return 0, right? Else of course return and number, right? Basically we're gonna use a 0 over here and plus and some recursion, and basically now we're gonna slice this 1 we forgot this. We have to slice inside our number, and we're gonna close parentheses, right? So we're gonna run this. So basically, you have seen something new thing over here that is known as slicing, right? So basically, I haven't made any video on the slicing because I'm gonna only make a video on slicing when you're using a pandas data frame, which is basically a 2D and 3D array, and it can be multiple array. So basically, right now, using slicing function without the pandas data frame is pointless, right? Because most of them we use for the data cleaning or the data analysis job, right? So right now we say return number, which basically 0 is basically indexing from the initial value of those number, which our number is our argument, plus some recursion, which basically we are recalling those function again, right? Then we're gonna index the number from indexing 1 to the end of the number, right? So let me show you how this this magical algorithm work, right? Basically people says code. I'll say algorithm because I love to call it algorithm, and it's more than a code. 1 2 3 4 5, right? So I'm gonna run this, right? And I will say result. Basically we're gonna save in our variables, right? So let's say sum recursive, right? Then I will say number, number, right? I'm gonna call this. Now I'm gonna call those result again, right? Now you can see over here the sum of them is 15. So if you want to validate this, let's say 1 plus 2 plus 3 plus 4 plus 5, that give us 15, right? So we have built an algorithm, right, which basically sum all of them, right? So similarly, if you use sum, right, there's a more easy way out. Let's say number, and you can see over here is a 15. That is a Python inbuilt function. We use a sum, open and close parentheses. So this sum algorithm is built into such way like this. So you can just type sum and open and close parentheses, and that will give your answer 15. So let's guys move on onto the control flow, right? So we're gonna use a functional programming again, and we're gonna do the same operations, right? Let's say sum iterative, right? And I will say number, right? And I will say let's say total, right? Total equal to 0, right? I will say for I in number, right? For I in number, then I will say total plus equal to that will be I, right? Basically gonna sum up, right? And say return, right? We're gonna return total, right? And because we have declared a number already on our top, right? Basically those are our number, right? Then I'm gonna say result again, right? Result equal to sum iterative. Then I'm gonna define an argument that is our number, and then I'm gonna call a result back again, right? Now you can see a 15 over here, right? So I'm gonna run this again, right? You can see 15 over here, right? If I want to make more complex, then I will say like for y for y in range, let's say 1 2 1 2 3 4 5 6, right? So there we go. It's did the most complex I'm like it has solved the most complex problem over here, right? You can see 1 2 3 4 5 6, that's a 1 to million. If we add from 1 to million, that will give you this much, right? It must be in a trillion, right? I will see you next time guys, and peace.